Dear students, today we are going to be discuss about computer organization architecture. In the computer architecture objective is we are going to be find out the differentiation between the computer organization and architecture. Understand the units of measure common to computer system, and also we are going to be identify the evaluation of computers appreciations, and we are going to be see the layered system computers to be understand, and finally we are discussed about the architecture of von Neumann and general functional basic computer systems. So von Neumann architecture will have the two layers of architecture, so we can stored and fixed, but in functional of basic computer components we can do store, retrieve, delete, update, whatever we can do. So this is the difference between the von Neumann architecture and functional of basic computer components. Now we are going to be discuss about number systems example. So in the number system example, we are going to be applied to three categories. One is general, another one decimal, another one binary. This is in the column row, and the row wise we are going to be discuss about the radix, digits, and the power of radix. So radix base is nothing but what is the base. So in general we say it as R, and decimal we say it as 10, and binary we say it as 2. In the digits we can calculate by 0 starting, and after the number we can calculate it by R minus 1. In decimal we can start with 0 to 9, and binary we can start with 0 to 1. So let me see here the power of radix. So we can see here in the 0, 0 we can apply to the general, we say it as R power 0. If you are applying to the decimal, we can say R power 0, that is 1 power 0 power 0, that is 1. And then binary we can apply as usual 1. So power of 1 we can say it as 10. So 1 10 power 1 10, 2 power 1 2. So like that we can apply the power to here, and we can process the number system in a base and then digits and power of radix. So we are going to be discuss about what is special power of 2. So special power of 2 means we want to find out either kilo or mega or giga. So that's why we want to apply the power of kilo means 2 power 10. So that's why we comes under 1024 is the kilo denoted by K. And if you want to get it the answer for mega, we can go for 2 power 20. So we get the value of 1048576 is mega and denoted by M. And if you are going to be applied to 2 power 30, we can get the value of 1073741 is giga and denoted by G. So this is the special power of 2. So it is 2 power 10, 2 power 20 and 2 power 30. Let me see here positive power of 2 useful for base conversions. Example, if you are applying the exponent component of 0, that is R power 0, we get it the value of 1. If you are getting the power of 2 power 1, we get it the value of 2. And then if you are getting the value of 2 power 2, we get it the value of 4. And next one we can apply to here 3. So 3 means we can give 3 power 2, so we get it the value of 8. So if you go to the 4 power 2, so we get it the value of 16. So like that we can go for the useful of base conversion to exponent value of powers. And finally now we are entered into the number systems. In the number system we are going to be discuss about number base conversions. In the number base conversion there is four types. Number one, binary to other number system, and decimal to other number system, and octal to other number system, and hexadecimal to other number system. So let me see here binary to decimal, binary to octal, and binary to hexadecimal, and decimal to binary, and decimal to octal, and decimal to hexadecimal, and octal to binary, octal to decimal, and octal to hexadecimal. And finally we are discussing about hexadecimal to binary, hexadecimal to decimal, and hexadecimal to octal. So here we are going to be discuss about octal number system. So octal number system can be classified into conversion of three types. One is octal to binary, octal to decimal, and octal to hexadecimal. So let me see here. First of all, octal to binary. So what is octal to binary? So octal to binary is a number system. We going to be conversion of, that is, base 8 to base 2. So how it is going to be do? So the base 8 is considered as octal number that will be changed into 0 to 7. So why we say it as 0 to 7 means, so we want to take the value from 0 to 7. So that is called 8. Base is 8. So we can take the value of 0 to 7. So whereas binary number is most familiar number system to digital system, networking and computer professionals. So let me see here. This is the table of octal to binary equivalent table. So first we have see about decimal. So what is decimal we are going to be see here means, decimal is the number we have 0 to 7. On octal we have the number 0 to 7. But binary we want to convert into zeros and ones. How we are going to be convert? So the number can be divided by 2 and we get it the value. Otherwise we can do by this one, 8, 4, 2, 1. So what is the number it's coming? We can put it. So here we want to get the answer of 1 means. So we can put 0, 0 and then 1. So likewise, so we get it the value of 001. So this is the answer of 001. Example now 4. So 4 is, we have this one. So we can put it there. So what, where to put means, we can put it here 1, 0 and 0. So see here, 8 is hexadecimal value. So 4-digit value we want to take means, that is called hexadecimal value. Only for octal we want to choose 8-bit. So 8-bit means we choose first three numbers. I mean right to left, first three numbers we want to choose. So that's why we choose it as this number and this number and this number. So let me see here what you are choosing. So 4 means we want to put it 1. So there is no other numbers we don't want to choose. So that's why 0. Let me see 5. So 5 means we can use, we can go for here 1, 0 and then 1. So 4, 0 and then 1. So 4, 0, 1. That is called 4 plus 1, 5. So that's why we can enable 1, 0, 1. So likewise we can apply the table to here. This is called octal to binary equivalent table. So octal to binary, how we are going to be work? So this is the algorithm they are going to be get it by 3 steps. The first step we can get it as, take octal number as input, and second step we take it as convert each digit of octal to binary, and third one we can get it as octal as binary number. So let me go to the first problem. So this is called 25. This 25 we can take it as the input. So we can take it as two different numbers 25. The 25 number can be write it like this. How we are going to be write? So already we discussed about that one. So once again I write it here. 8, 4, 2, 1. So what is the number? 2. So in octal number we want to choose only three numbers. So that's why 0, 1, 0. So see here. So this three numbers we want to take it for octal. So 1 we don't need, 2 we want to enable. So that's why 1, and 4 no need. So 0. So that's why we written here as 0, 1, 0. For 5, 1, 0, 1. So that's why 4 plus 1, 5. So 2 no need. So 0, 1, 0, 1. So see here students, 0, 1, 0, 1, 0, 1. So this is the binary bit. The binary bit can be assigned by the base numbers. So how we are getting the base number means, let me see here, 2 power 0. The right last number we want to choose it as 2 power 0 and then 2 power 1 and 2 power 2. This is called radix number. That is called, we say it as exponent. Exponent number we can say to here. So this is we are doing to apply the base value or radix value. So combine this all the 6-digit number, that is answer for 25. So we can combine 010 101 and then we want to choose the base value. How we are going to be choose base value? So let me see here. This is called 25. The number it is called input is called octal. So that's why the base number is 8. But we are converted here as what? We are converted the number as binary, so we want to put the base value as 2. Okay, so next we go for the next thing, 540. 540 is also the similar to that one. The 540 we want to convert it to, what is the value? 101 100 and 000. What is 540? 5 is called 101. So already we are discussed about the number conversions. So once again I write it here. So how we are going to be write it to there means, we can use 8421 and then we can apply the value of 5. So what is the 5 value? We can apply 101. Next 4 100 and next 0. So no value 000. So these are the thing we are just tell it to there. In the concept we are telling 5 4 and then 0. So combine all the things and given the base value of the binary is 2. And next is students, this is a new one. So what is a new one means, we are discussing about the this 12 you know to do. Okay, so as usual you are going to be do that one. So what you are do, 12 we can do 001 and 010, but new thing we are applying here as point. So what is point? So after the number will have decimal values. So how it is going to be do? So we can keep it here as the point separately and find out the answer for the 5 as 101. So combine all the things, that is called this number for 1 and this number for 2 and this number for 5 and then give the base value as 2, similar to that one 721. Okay, so this is the simple example for octal to binary. And similar to that one students, for 352, so for 352 we given us 0011 and then 5101 and then 2010. Okay, so this is the concept we are taking as the input. In the input we can say it as the answer of 3 and then answer of 5 and then answer of 2. Okay, so similar to that one 5 6 and then 3. So always students you must keep it out. The IC number is 8421 for the number system for calculating, one for octal, another for hexadecimal. Okay, so octal is the concept to getting the value for 8-bit. Okay, so octal is always called 8-bit concept. Okay, so we can do that one for 8-bit and hexa we can use for 16-bit. Okay, so 8-bit means we want to choose this one. Otherwise if 8421 for hexa, we want to choose all the number as for hexadecimal. So this is for octal and this is for hexadecimal. Okay, and next thing is octal to decimal. So octal to decimal as usual the same thing. So what you are going to be do means, we can go for the concept of power. So in the power of 8, the power of 8 we can say it as this is called octal, but in the octal conversion can be converted into base 10. So base 10 is called decimal. Okay, base 10 is called decimal. Next one, octal to decimal. In the octal to decimal, how it is going to be conversion means, first we want to start the problem by 6 4 2 7 and 3. Okay, so we want to apply the power. So how we are going to be apply the power means, first let me see for the 6. So 6 we can apply for 8 power 0 and 8 power 1 and then 8 power 2 and then 7 8 power 3 and then 3 8 power 4 So we can tell it the number in the left hand side like this. So in the left hand side, whatever the input numbers we are given in the left hand side, and right hand side we can give the power. So multiply and find out the sum value. The sum value is the answer of decimal. Put the bracket and say it as this is called answer of base 10. It is the answer for 372468 base 8 can be getting the value of 16038 base 10. This is the conversion of octal to decimal. And similar to that one, students, this is the conversion of, as usual, the same of previous slide. So one new thing we can tell it to here. The new thing is called 0.43. So how it is going to be do? So 1725 already you know. So you can give the value of 5 into 8 power 0, 2 into 8 power 1, 7 into 8 power 2, 3 into 1 into 8 power 3. So like that you can give, but 0.43 how we want to give means 4. So let me see that one. So we can give 4 into 8 power minus 1, and then 3 into 8 power minus 2. Okay, so if you are multiplying this and this answers, we get it as the answer of 0.5 and then 0.00046875, and finally we get the sum value of 981546875, and we get put the value of combine all the values of 98 and 0.546875 base value 10. So this is the conversion of octal to decimal. So in the conversion of next one, octal to decimal, the similar the problem. So as usual we can do 7 into 8 power 0. So 7 into 8 power 0 plus 1 into 8 power minus 1, all the things. So let me find out the answer of the here. So what is the answer we are telling to here means 10.1599. So we can multiply, we can add the value of this one to this one. Okay, this one. So we get it the sum value, and then the remainder value can be added to this 7. Okay, this 7 we can add at the value of the remainder sum value, and we get it the answer of 10.1599. Okay, this is the another conversion of octal to decimal. And next thing is octal to hexadecimal can be do by two steps. One is called binary digit, another one is called binary to hexadecimal. So what is the difference? Let me see here. So this is the number we are going to be see about octal to hexadecimal by the table format. The first table we are going to be discuss about, we can use decimal values 0 to 16, 15. So why we say it as 16 I told. So why we take it as 15 means that's why we take it as the initial value of 0. So 0 means 0 to 15. But hexadecimal is also the same number, but after the 9, okay, after the 9, the 10 will be started by A. So hexadecimal no value of 10. Okay, so that's why we given us the value of A, and then next B, and then C for 12, and D for 13, and E for 14, and the F for 15. Okay, so let me see here as usual the same conversion one, and let me see how to convert that one. So similar the same thing. So how we are going to be do means by using of 8421 is the IC number. So for 0 we can put it as all the numbers are 0. And if you need 8 means what is the number? 8 we can put it as the enable of 1, and 4 no need 0, 2 no need 0, and 1 no need 0. So that's why we get it the answer of 1000. So for 9, so we can go for 9, 8, 0, 0, and then 1. So 8 plus 1, what is the value? 8 plus 1. 8 plus 1 is 9. So that's why we can enable this one 1001. So this is the number we get it the answer of 9. Similar similar to that one, we can we can get it the value of this all the numbers. Okay, and go for the conversion now, octal to hexadecimal. So the input is 5456 base 8. We want to get it the hexadecimal form, that is we want to get the answer of in the base 16. Okay, so first we take it as the value of 54568. What is the input output of 16? So first the 5 4 5 6 to be converted into octal numbers, that is 5 is 101 and 4 is 100 and 5 is 101 and 6 is 110. So now we can combine all the values into the bracket and put it as the base 2. The first thing, the octal to hexadecimal not possible to convert directly. So first of all we want to convert it to binary format, and then we want to convert it into hexadecimal format. So that's why octal to hexadecimal there are two tuning. Okay, first tuning is octal to binary and second tuning is binary to hexadecimal. Now we are get the value of binary. Now how the binary number going to be changed into hexadecimal? So first of all we have the value of, what is the answer? We get it the answer of 101110101110. Okay, so how are you going to be find out the answer of hexadecimal? Means first we choose the first four numbers from the right to left, another four from the right to left, another four from the right to left. So we want to take the value of in the right hand side to left hand side 4 numbers. So why we are choosing 4 number? Means hexadecimal is 16 bit, so 16 bit means we want to choose 4 power 2. So that's why 4 numbers we want to choose, and then we get it the value of hexadecimal. Okay, so this is the answer of hexadecimal. For 11 we don't have numerical value of hexadecimal, so that's why we given us B. In the previous table it's given, so that's why I am telling here. So for 9 only numbers, after the 9 we say it as 10 for A, 11 for B, 12 for C, 13 for D, 14 for E and 15 for F. So now 11 is B and 2, so as usual 2 given number, and 111110, the number is 14, so we can give us E. So now the answer is B to E base 10. Okay, so we are discussed clearly about the number conversion of octal to binary, octal to decimal and octal to hexadecimal. So any clarifications? So let me see in the next video.